Hello everyone in internet and TV land. Welcome to the presentation on building resilient, scalable IoT workloads with the AWS IoT Core. I am Rudy Chetty and I'm a solutions architect for AWS. And let's take a look at our agenda. Well, we'll start with a refresher on the AWS IoT Core. We'll go into an integration example. We'll then dive into a use case by Amazon Key for Business, along with an actual demo. We'll give you a summary and then wrap up with some resources that you can check out after the video. So let's get into it. So to understand what AWS IoT offers, you have to understand what is the AWS IoT Core. And you have all these things in the fields or devices, and they need to connect into something on the AWS platform. In this case, it's the AWS IoT Core, and they're sending messages continually to this particular service. From there, you can route them to other AWS services, whether it's AWS Lambda, Kinesis, or even Amazon Elasticsearch. You can also republish messages. So if you needed to do some conversion between, say, Celsius and Fahrenheit, you can do that and then republish to the AWS IoT Core itself. Now the core, if we kind of expand into it, has these features: the identity service, device gateway, and so forth. And let's kind of touch upon each one of them. So we'll start with the identity service. Now what this does is it allows your devices to authenticate to the AWS IoT Core with X509 certificates. Now if you've never looked at one before, this is an example of a certificate. Obviously it's kind of trimmed for brevity, but you can see that the certificate is kind of obfuscated in a way that it's not replaceable or reproducible. You can also connect with signature version 4, even token-based authentication. So your devices have plenty of options when connecting to this particular service, and that being the AWS IoT Core. Now, to give you an example of using the command line interface, this is an example here of creating keys and a certificate. We've even put in the values that you can put in so that you can generate them with certain names. In this case, we've called them certainly, and you can see that we've got the PEM files being generated and the public keys as well. You can also look at IoT policies. So once your device authenticates, what is it authorized to do in AWS IoT? So that's where policies come in. And if you've ever looked at identity and access management policies, these are very similar in that they're JSON-based documents that allow you to authorize or deny access to certain parts of the AWS IoT Core in this case. We also allow you to use services like Amazon Cognito. Now, Amazon Cognito allows you to separate your users, your end users, and your infrastructure users logically. You can also federate to existing identity stores and so forth. So now that we've connected our device, how do we kind of go from there? Well, we use the device gateway. So we've got our thing sitting on the left and our device gateway, and it opens up a bi-directional long-lived connection. What that means is you can send data to the device and the device can send data to the device gateway. And it does that over several protocols. In this case, MQTT, WebSockets, or HTTP. MQTT being messaging, queuing, telemetry transport, and it's a much smaller payload than HTTP, so it allows you to stream more updates more frequently. This connection is also secured via TLS 1.2, so that's a protocol that's the sequel to SSL. And if you have devices that are using an older one, we recommend that you upgrade to the more recent version, which is 1.2. Now, as we go along, we've connected, our device is sending messages, thinking, well, how do we route those messages accordingly? Well, we use the message broker. In this case, it makes use of a IoT topic, and you're actually given some out of the box. So you've given reserved ones, and you can use wildcards. The reserved topics start with $AWS, and wildcards could be an asterisk or even a hash sign. Now, they operate on a publish-subscribe model. So you can see here, the thing, in this case, it looks like a kettle, is brewing coffee. And in this instance, it publishes one message, and you've got multiple subscribers who are looking to say, well, I want to know when the coffee's ready so I can go and make a cup. And the pub-sub model works on a one-to-many, which allows you to publish one message and receive that message along multiple subscribers. You also have access to offline queuing. So if the connection between these particular devices and the AWS IoT Core is disrupted, you can queue those messages so that you don't lose them. We also have support for QoS 0 and 1. What that stands for is quality of service. Now, 0 is when you deliver the message 0 or 1 times, and 1 is when you deliver it 1 or more times. Now, we don't support QoS 2, which is exactly once, but we do have something coming up which helps mitigate that issue. So we've sent the messages through now, and we're thinking, well, we want to route them accordingly. We make use of an IoT rule, and that is a data transformation paired with an action. Now, the data transformation is very kind of familiar to those of you familiar with SQL. It's a select statement. So you can see select star from topic slash XYZ where the temperature is greater than 35. In this case, it's probably 35 Fahrenheit. For where I'm from in South Africa, it's probably 35 degrees Celsius. Now that message gets sent through, and we select it out or pull it out, and we can perform mathematical functions on it right out of the box. In this case, if we were converting between Fahrenheit and Celsius, we can do that using these built-in functions. We can also do string manipulation, date formatting, and so forth. We can also enrich it. So if we wanted to, say, geotag a location onto it, we can run a Lambda function in response to this select statement and then say, okay, well, I've got this temperature, but I want to know where it came from. And then you can put it into that particular value before you pass it on to the action. And you can see here with the actions themselves, the messages can either be republished, as we mentioned earlier, or they can be routed to other AWS services. In this case, you can see AWS Lambda, S3, Amazon DynamoDB. You even have access to third-party services like Salesforce. Now, as we go along, I mentioned with the QoS version 2, or sorry, QoS 2, is we don't support that because we support a very reduced MQTT 3.11 protocol. But, obviously we want to offer customers options. We give you the device shadow as a way to actually mitigate that. And what the device shadow is a logical representation of state. So your device is sending its state to the cloud, and the cloud is replicating that and saying, well, I know what the state of the device is based on this device shadow. So you can see your thing here on the left, it's sending messages, and you can send it to the device shadow, and an application interacting with it can likewise read from the shadow itself, so it doesn't have to go to the device. And you saw that we had a different state going through from the right to the left, so from the application through the device shadow and to the thing. What that means is that the application is saying, well, I know that's the current state, but I want to change that state. So I'm going to actually say, this is what I want you to change it to. But it's kind of fun to see it as more of an example. So, actually, you know what? Looks like our thing has been disrupted. Does that mean we lose access to the device? No, actually we don't. Because of the SDKs and APIs, we can still interact with that device shadow and not actually rely on whether the device is up or not. And that allows your applications to not be disrupted in any form. But like I said, we want to look at an example. In this case, you can see several different portions to this JSON-based document. The first one to look at is right in the middle there, the reported, and that's what the device is reporting to the cloud. So in this case, the color is red, and that's what it's reporting to the device shadow. But say, our application wants to change it to blue. That's where we set the desired state. So once we set the desired state, that goes to the device shadow, and then from there to the actual device, and then it'll update itself, and it'll report back that it's changed its state to blue. The other part to mention is the metadata portion. And you can see here the timestamp of when that particular change was performed, and also a version. And that's pretty important because if you want to guarantee order, you can look at the particular version. And in this case, it's 769. So the next version number would be most likely 770. Now, the last thing to mention on the AWS IoT Core, or the feature lists that fall under it, is the registry. And you're probably thinking, well, I'm going to start with one device and get that up and running, maybe 2, 3, 10, 10,000, 20,000, a million. It's going to get pretty difficult to search through your devices to find the one that you're looking for. So we introduced the device registry. You can see I've said we've got several devices. and it just keeps piling up, and trying to isolate them is pretty difficult. So with the registry, what you can do is assign thing types. So in this case, we've got a bulb thing type. So any bulbs that come through, we can assign them that thing type. And in the other case, it's a blood pressure machine, and we've assigned a relevant thing type there too. What you can also do is go one further and group devices. In this case, we've created a transportation group for a plane, a bicycle, and a car. And you can also run jobs against these groups. In this case, you want to find out the location of all of those devices. You can create a a job that goes to all these devices, and you run it once against all of them to say, what's the location of that device at that particular time. But you know what? Customers asked us for even more, and I'm going to give you a bonus slide here. The AWS IoT Greengrass service that we have. So customers said, well, we love the functionality that you have on the cloud. Is there any way to extend that to the edge? And this is where we introduced AWS IoT Greengrass. And what it does is it allows you to do local messaging and have triggers that can be triggered as well. So if you've got thing A and thing B and they need to communicate with each other, usually you'd go through the cloud. But again, if that connection has been severed, you still want to have that functionality. So with Greengrass, you can send a message from thing A to your Greengrass core, and that gets routed to B, and then B's got its message. There you go. You also get access to local actions. So what that means is if you have a device that's connected to this IoT or AWS IoT Greengrass core, you can effect an action on it based on any number of variables. In this case, let's say the temperature on thing A has spiked and we want to turn on the fan. So that message goes through to the AWS IoT Greengrass core, a Lambda function gets invoked, and the fan turns on to help cool you off. We also have data and state sync. So you can send data to the IoT Greengrass core constantly, but maybe late at night is when you want to actually sync it. And then at 8 p.m. you say, you know what, I'm going to send it up to the AWS IoT core, and that allows you to aggregate all the data and send it in one go versus sending multiple updates. We also have, built-in the same built-in security that you're used to. The TLS 1.2, we've got encryption, and it's the same level of security you're used to with many of the other AWS services that we provide, such that only authorized and users that have been authenticated, or services, or in this case things, have access to your Greengrass core. You also have local resource access. What that is if you have devices that are connected, so in this case a hard drive or even low-level GPIO pins, you can actually connect to those through your core and perform actions on them. So whether it's reading a file from the hard drive or turning on a sensor that's connected via GPIO pin, you can do that. You know what? This is one of my favorite options or things here. It's machine learning. I mean, it's a very hot topic, but at the same time, we've got access to machine learning services through the AWS IoT Greengrass core. And what you can do is train your models using SageMaker, our machine learning service. You can export those and then run them on your Greengrass core. Even better, if you have a GPU or graphics processing unit connected to your core, you gain access to it. And you can use that to supplement your machine learning workloads. We also have various connectors. In this case, you've got AWS service connectors and third parties. So whether it's ServiceNow or Twilio, you can connect to them using Greengrass connectors right out of the box. And that allows you to not only extend your functionality, but maybe you have an existing service that's utilizing one of these third parties, and now you can port it over to your Greengrass core using a connector. And over-the-air updates. I mean, this is something that most people who have smartphones are used to. Sometimes you'll see it says update available and you have to click install or decline. And in this case, we offer that piece of functionality with the AWS IoT Greengrass core. And if the update goes through, you can see, okay, it's installing, and cool, Bob's your uncle, we've succeeded. If it doesn't succeed, it is failover that's built in. And you can stream these updates over MQTT, which is, I suppose, very useful because that's an easy way of getting them to the Greengrass core in this case. But you know what? Again, we've been talking about this for a while. Let's go into the examples. I mean, that's the fun bit that you've been waiting for. So let's look at an integration example. In this case, we'll go through an architecture, and you can see that I've got a very handsome gentleman here who's had his face indexed in the Amazon recognition service. So it's available to kind of run against videos or images to see if that face is in a particular video or picture. And then we've got a camera connected to a Raspberry Pi, which again is sending a video stream to Amazon Kinesis video streams. That in turn is sending that video to Amazon Recognition to see whether that face exists in any particular video or any of the frames. From there, if a record is found or if it isn't found either, it goes to Amazon Kinesis data streams. So if a record's found, it says, look, I found this face, and then you want to think, well, how do I perform something on that? Well, you use a Lambda function, and then from there, you can output to an Amazon S3 bucket to say this face was found in this particular frame or this particular video, and then you can visualize it using something like Amazon QuickSight. And this is a very, I'd say, used architecture for video stream recognition. And you're probably wondering, well, where does AWS IoT come in? Well, it's right here on the left-hand side. We can actually bundle up the camera and the Raspberry Pi as a thing, and then connect into the AWS IoT Core, or better yet, we can actually use AWS IoT Greengrass and create that as a core itself, such that you can use over-the-air updates, all those local access that I mentioned, so you'd have access to the camera because it's connected to the Pi. And then from there, you can see how we've gone from a standard video streaming architecture to integrating AWS IoT or even AWS IoT Greengrass into that architecture. Well, next up is, Amazon Key for Business. For those of you who don't know, what do they do? Well, Amazon Key for Business it's a company that kind of, or not company, it's a part of Amazon that helps with delivering packages from your source to your destination. And if you're wondering what problem they were trying to solve, it's that last mile that they have, where your package goes from the driver to your front door, if not your gate, or even the assigned area in your apartment complex that you can deliver to. And what they found is in most of these complexes, it's gated or it's security controlled. So when they're trying to deliver the package, they go, oh, cool, oh, sorry, it's locked. And then the delivery associate has to either leave it in an insecure location, or maybe they, sitting there going, well, I have to attempt a redelivery. And all of those add up over time because we couldn't get a hold of the customer maybe, or like I said, it's, access controlled. So, the last mile team went about solving this in the way of introducing Amazon Key for Business. And they went about a prototype phase. And what they did there is, instead of searching the web for all these pieces of hardware they could use, they went straight to the AWS Partner Device Catalog. And what that is a curated list of devices that run or that are qualified to run with the AWS IoT Core, if not run Greengrass or Amazon FreeRTOS. And Amazon FreeRTOS being the Amazon-flavored version of FreeRTOS, or Free Real-Time Operating System, which offers AWS Cloud libraries, so you can integrate directly into AWS using the extended libraries. It also has local library access, so you can connect to Greengrass cores, Wi-Fi, even Bluetooth low energy or Bluetooth itself. And the team kind of sat there and said, well, we want to use something that's out of the box. And they decided they want to look for something that supports Amazon FreeRTOS. They even wanted access to the security features that come with it. As I mentioned, the TLS 1.2 and the over-the-air updates, or OTA, so that they could update these devices in a very easy and reproducible fashion. They went one further and they found an actual board, in this case the Curiosity board, and they picked it specifically because they could add on to this board. They added on cellular connectivity to double check whether they could connect to the device apart from Wi-Fi. It also had Bluetooth functionality, and they could connect a building access controller. And what that is it's the system that's connected into the building that allows these particular gates, whether it's the gate at the front entrance or it's your sliding garage door for your cars to drive through, and it allows you to open and close those using this building access controller. So that's why they chose this particular board. Now, Amazon Key for Business itself, how do they go about pairing that with something that would be useful for drivers? Well, they use the Amazon Flex app, and they paired it with what they call a smart fob. So I don't know if most of you should be familiar with a fob, but it's a little piece of, let's say, plastic that could be an RFID tag, and you can swipe it in your building such that you can enter after it's authenticated that you are someone who's authorized to enter it. And for the Flex piece, what it is it's it's a service that we offer where customers or delivery associates can sign up and they can deliver for Amazon kind of at their leisure. So they have a flexible schedule, and they thought, well, you know what, since we already have this app, let's provide the perimeter access to drivers using this particular application. And you can see there in the screenshot, you've got 2 buttons there for unlocking the front door and the elevator. The smart fob itself, they built one after they went through the prototyping phase, and it integrated with 98% of physical access control systems, and those are the ones that I mentioned where they connect into your buildings and they allow you to access certain areas using fobs. It was secured by AWS IoT. As I mentioned, it's running Amazon Free RTOS. And in that case, you had access to all the libraries that we mentioned and the TLS 1.2 with encryption where you need it. And it was cost effective. I mean, it was about, I think, $75 per device, which kind of scales out pretty nicely such that you can go one further and say, you know what, we're going to install this into existing buildings so that have existing packs, and there's no impact on the existing residents. So if someone has access before the device has been put in, and they will still have access once the smart fob has been installed, which is pretty impactful in the sense that you don't affect existing residents, and you also open it up for the delivery associates to improve the lives or improve the deliveries of packages to residents themselves. And you know what? It wouldn't be complete if we don't show you an architecture diagram. So let's go into that. We've got our residential or commercial property. In this case, we've got the smart fob installed along with running Amazon Free RTOS. That connects into our AWS IoT Core via MQTT topics, and also directs messages using an IoT rule. We've got the delivery associate who's got his nice little Amazon badge there coming in, and this person is using the smartphone application running Amazon Flex. That goes in once they've pushed the button to an Amazon API gateway, which is a RESTful API service we have on AWS. That then calls a Lambda function, which interacts with the device or the smart fob through those topics that we mentioned, where you can have bi-directional communication. We also have a DynamoDB database, which is storing particular data for that, whether it's which building it is, when the access was granted, and so forth. And then you go into a data pipeline, which puts everything into Redshift so that your BI folks are all happy, such that they can run business intelligence reports and perform analysis on data sets. And one more thing to mention is that because of the I'd say the feature-rich product or AWS services that we have, the team decided to use AWS IoT Analytics such that they could just route the data accordingly and then perform analytics using that service, which comes out of the box. So that's Amazon Key for Business, and you know what? It's always fun to see a demo. So let's click through and play that video. So what were the highlights of using AWS IoT for this particular workload? Well, the team said that it was fast, it was seamless, they had secure communication between their devices and the AWS IoT Core, so they could guarantee the safety of data going across the channels. They used device management and monitoring, What that means is they could monitor all the devices in the field, and they could manage them with over-the-air updates, or if they needed to patch them or take a device out of rotation, if something happened with that device. It reduced the dev cycle on the embedded device in the sense that they could get a device up and running in about 3 months, and maybe in 9 months they would actually have a production-ready device. And that's thanks to the partner device catalog and the support of Amazon FreeRTOS. And the over-the-air solution. So as I mentioned, the over-the-air updates are something that they took advantage of, such that they didn't have to have people in those buildings send the devices back to them so they could update them, or so they could just do it over the air. And data collection, as I mentioned, the usage of AWS IoT Analytics and even Redshift, out-of-the-box integration that they didn't have to go in and build themselves, and it made it a lot easier to get the data they needed and perform useful analytics on it. So we've just talked about Amazon Key for Business, but let's go into another example using AWS IoT Greengrass. Now, what we have here is a smart warehouse. So think of it as either a fulfillment center or a warehouse where you're performing functions that require access to the cloud. So in this case, we've got a secret warehouse gadget thing. It's a very technical term for something that is not shareable under NDA. That's connecting into AWS IoT Greengrass. So we've got a core running in the actual warehouse itself. And that connects in bidirectionally to the AWS IoT Core. So it's sending messages to the core, and the core is responding accordingly. And that's being monitored using Amazon CloudWatch. So again, we're getting useful metrics. We're checking out KPIs and whatnot. And then from there, we're also redirecting or directing data via an IoT rule to Amazon S3. And the reason we're doing that is so that we always have a record of what happened at that particular time. So we're storing it for historic purposes. We also have a Lambda function which connects in to the AWS IoT Core, and that allows us to connect to backend services that might not be as cloud-enabled as we'd like. We also have the Greengrass core calling into API Gateway, and that allows us to call Lambda functions in the background and go to Amazon SNS, or Simple Notification Service. So say a package goes out and we want to send a message or send an SMS message to a customer to say, hey, this has actually been shipped out to you. We can use that particular service to do that. So Amazon SNS supports SMS, or short message service. So enough talk. We've come to the demo portion of our presentation. So let me take out my little friend here. So we've got an ESP32 here connected to AWS IoT Core. You can see that we've got some green LEDs to show you that there's at least a state change. I also have IoT Enterprise one-click button. What that allows you to do is kind of get connected with the AWS IoT Core very quickly, in the sense that you can press the button, it'll connect to the AWS IoT Core, and then call a Lambda function to perform a particular action. In this case, I'm going to push the button, and it's going to change the color of the LEDs. So let me try that. I'll push it once, and let's set it down here and see what happens. I wonder if the Wi-Fi is behaving. Well, looks like the Wi-Fi is still connecting. Let's try that one more time. Okay, well, looks like the device has changed and sent the signal through. There you go. We've changed the LEDs to red in this particular case. I'll try it one more time to see if we can get a blue color going. It's a very festive color. It matches my purple shirt. Oh, and we've got blue as well. There you go. So, that's the demo. But you know what? Again, we want to make sure that you have all the pieces to the puzzle. So let's switch back and look at the actual architecture for this demo. Now we're starting on the left-hand side here with the AWS IoT button. That's the one I showed you that allows you to connect into the one-click service and call Lambda functions. Now, as we click the button, that goes to AWS IoT one-click, and via an IoT rule, we go to AWS Lambda. Now, to give you an example here or kind of illustrate is that we're actually recording the type of click. In this case, the single, the double, and the long click, which are the three types of clicks that come with these IoT buttons. And I've assigned different actions such that it will change the color accordingly, depending on the click type. We then go to the AWS IoT Core because we want to call back into the ESP32, which is connected to our LED strip. And we're saying, well, I want to change the state or change the color of those LEDs. And in this case, it's the desired state. So we say, okay, well, I want to change the color to green. So we send that desired state through, the LED strip changes to green, and then you think, well, that's the end of it. It's like, nope, not just yet. You need to report back from that device that the state has changed. So we actually report from the ESP32 back to the AWS IoT Core that the state has been affected, so that we know not to send that state again. And yeah, that's the demo architecture, and you can see how we've integrated two IoT devices via the AWS IoT Core. And thanks for joining us in this presentation. Hopefully you've learned a lot about the AWS IoT Core. And in this case, you'll see how you can connect multiple things to your AWS IoT Core, whether they're running the SDKs, using APIs, running Amazon free RTOS in the Amazon Key for Business example, or even an AWS IoT Greengrass core that also can connect into your AWS IoT Core. And as a closing or a parting gift, I'm going to show you some resources that you can dive into after this course so that you can learn even more. We've got the partner device catalog listed there, 2 IoT All the Things episodes, which talk with various customers. And then we've also got another presentation on IoT building blocks, the Thing device shadow, and even a workshop using Arduino where you can connect a ESP32 to the AWS IoT Core, push a button on it, and then actually send yourself an SMS message. So once again, from myself, Rudy here in Seattle, thank you for joining us, and have fun on your reInvent journey.